Ooh. Very good. Is live. Perfect. Okay. Let me close this thing. Let me. Good. So. Very good. Welcome everybody. We are for the first meetup after the summer. Yeah. Tonight we will talk about scaling backups, scaling hot standbys, scaling everything. The talk it will be quite straightforward because it will cover the last 4 years of our fictional DBA. I will present the Dramatis persona after in the before starting the presentation. So we will cover the 2012, 2013, 2014, 15, 16. We are still in the 16, but our DBA moved into different places, more challenging, maybe. So, oh yes, just a little warning. This story is true. I can swear, it's true. All the names are changed to protect the innocent. Who is taking who catch the quote of this thing? You know, Dragnet. Okay, let's introduce the Dramatis persona, our characters. A brilliant startup, Acme, let's give a name, like Wile E. Coyote, the main supplier of the tricks against the Roadrunner. Then we have the clueless engineers. We work fine in them, all burning in them. Then we have an elephant in steroids, blue, beautiful, powerful, and like I like to say, is a bloody masochist. It just works. You can mistreat, you can make any mistake, but that thing, it just works, and it's beautiful. So anything unrelated with elephants is irrelevant. Then we have the big cheese, the money, the hardware. Who had the Commodore 64? I had the Commodore 16, I was poor. But then I moved into the Commodore 64 later when it became cheaper. Not this shape, it was the new design, but beautiful, beautiful system. And finally, our DBA, the real hero, the man who worked against all odds. So let's start with our stories. In the beginning, before starting everything, 2012, the DBA moved into this new job and he started the onboarding. He met new colleagues, he started looking into the systems, and then he started the 2012. Who am I? What I'm doing? I love this picture. It's the picture that marked my university life. The introduction of to the errors. It was on the front page of that book. Absolutely fantastic. The Montpellier derailment. So let's see how DBA. He started working with pretty large scale, not really big. It was about small logger database, 50 gigabytes. Larger configuration, just 200 gigabytes. 2 archive DB, 4 terabytes each one. Use it for pulling the data out, ETL, and put into the business intelligence database, which was just 2 terabytes, very small compared to the final situation. Each database, the counterpart hosted on a less power hardware, so doing any failover, it was quite complicated because it meant slow performance for the time of the failover. And yeah, I won't tell anything about the first 3 databases. We will focus on the fourth database, the business intelligence, which had some sort of interesting story to tell, how things can be complicated. So the DBA started talking about things. It started looking to the databases, write down things, analyze the tables, look at to the statistics, look at to the CPU utilization over the different things, and we found interesting things like the lagging standby. At some points during the day or the night, the standby started lagging with a large amount of that data accumulated onto the archive, or not really the archive. The problem was the second part, but we have a suboptimal schema, and please, schema, because it's very difficult to define schema, what our DBA found, and churning table constantly, tables and indices. rsync, it was used as archive command. So over the big bunch of data hitting the world directory, it was also an extra overhead caused by the network latency. And every time an rsync, for each archive command, a new rsync was spawned. It wasn't constantly in place. It was called for each WAL file archive. So it was a massive threat because we had ready files in the PGX log. Do you know what the ready files are? Okay. Ready files are files with the same name of the WAL files and tell the database do not recycle those files because they are not yet archived. So it means I still need it because my slave, we haven't received it yet. But that means that not recycling the WAL files on the master, it can grow up the WAL files directory, and if it runs out of space, database crash. Live database crash. That's bad. Very, very bad. Then we had another problem, the base backup. There was a rudimentary init standby script for creating new hot standbys. It was just PG start backup plus a rsync for each table space inside the business intelligence database. As far as I remember, there are 4 table spaces. There were 4 table spaces. So he has to run through the first big bunch of data, run through the second. It took a very long time. Sometimes it took up to 24 hours to rebuild one single 2 terabyte hot standby, which means 24 hours without failover. Crazy. So let's see how to solve this thing. Oh, there's another thing. I forgot this. Slow dump. There was the slow dump. This was another interesting thing. Each cluster was dumped remotely by a central server. So the central server called PG dump, connected remotely to the slave, to the master database, and pulled out the data locally. The result, it was from 3 hours to 2 days to take a PG dump in custom format, compressed. And yes, the business intelligence, this was the 2 days, it was very corner case. It was the archive database with bloated data, problems, even old artwork. But the business intelligence database, it was quite good in terms of artwork. So it took about 14, 18 hours with constantly increasing in time. So moving dangerously through the 24 hours overlapping because it was backed up every day. So finished the 2012, our DBA started in the end of 2012. Start the new year and on thin ice, moving baby steps over the thin ice to avoid disasters. Because one of the rules of thumb to be a DBA is to try to get unnoticed, try to do things without anybody noticing, because if somebody notices, it means you are doing very, very bad, you are doing wrong. So the first thing, it was, let's get rid of this rudimental rsync script for the hot standbys. Let's use a parallel rsync. One of the interesting things you can play with the bash scripts, you can spawn processes, grab the process ID, store inside a bash array, and then look to the bash array to prove the presence or not of the PID, and wait until all the processes are exit. So for each table space, which was mapped inside another bash array, our DBA loves the bash arrays, or the arrays in general, there was a different process, rsync process. Before these processes were spawned, there was the usual PG start backup to tell the database to start the Postgres backup, mark the backup label, and then finally all the processes were spawned. Another interesting thing, it was, so this thing, it was good and bad, because in some way hammered the network, because it was 3 times the amount of network occupation when syncing the database. In particular, it was if it was a fresh new hot standby without data on the other side, the entire database flown through the data. So but that thing, it worked pretty well. And the time for rsynching the database, it took less time, up to just 12 hours, and shrinking. Meanwhile, the hardware became better and the network became better. And plus there was after the PG stopped backup, there was an email sent to the DBA and say, hello, you can start the backup, you can start the slave. Because before, there wasn't any alert. Every now and then, the only solution was to log into the machine and look at the logs if they were still rsynching or not. In this way, it was quite simple to get the alert from the database itself, from the system itself. Oh, this was another thing. Local archive, instead of rsynching over the network, the DBA added a simple CP command to copy the WAL files into a local directory. More space local required, because the archive required more space to avoid any risk of filling up of the PG xlog. Because another thing about the ready files, if for some reasons the archive fails, the ready files accumulate. So if the archive directory fills up, sooner or later the PGX log will fill up as well. So it's good to have 10 times bigger archive directory compared to the PGX log. So it copied locally, and then a simple script at that time then changed several times to match the more requirements by the business. There was this script rsynching every minute to the slave, and grabbing with a simple use of AWK plus sed plus something else from the PG control file on the slave to grab the last restart point. The last restart point is similar to the checkpoint. It's the last consolidated point in space on the slave, in order to grab this information and clean up locally on the master the archived file using the information on the slave. There's something changing in the 9.6. The 9.6 finally exposed this information as view. Finally. That's beautiful. I cannot wait for the 9.6. But now, there's still the 9.5, where I still need to SSH on the receiver box and ask for PG control data to get the information of the last restart point. So, using this script, all the ready files disappear, because local copy, it always succeeds, and then there's the copy on the other side. Other problems, I'm not talking about this, but obviously the network latency is important, because if you copy a big bunch of data over the streaming replication, the network can be hammered in any case, but at least the master is not at risk of crashing. That's beautiful. That took, I think a couple of months to find out the problem. At some point in the day, the slave just lagged. 12, 20, hundreds of gigabytes of lag for no apparent reason. No load on the master. The slave was the same hardware of the master, but just lag. It was crazy. And after experiments and after reading the source code, the problem was this: if you have a table where vacuum is running and you update even a small amount of data on that table, the slave lags, accumulates lags. As soon as the update stops, the slave stops lagging. This is caused by it's normal. I remember it was filled a file a day bug number 8192. Pretty topic. Pretty crazy. It was the block size of Postgres. And Simon Riggs answered said, no, that's normal. This was a specific design because we needed to be sure the data was replayed safely on the slave. Basically, when this happens, this concurrent case happened, at least it was understood by the source code, one tuple can loop through all the indices, updating and vacuuming all together in the replay process. So it can stay over a single tuple for some time. And when the updates on the other side are accumulating, the lag accumulates. So nothing to do? Yeah, it was just the Autovacuum causing this thing. So the solution, not really a solution because it was just a workaround, it was to use the Autovacuum nap time. The Autovacuum nap time is a way to tell the Autovacuum to stop every now and then. Every single action, index read, tuple access, tuple freeze, tuple cleanup, you have an arbitrary cost inside the Autovacuum logic. So accumulated these numbers up to a specific number, and then nap for a minute. Then restart doing it, and then nap, and then restart. So the action was Autovacuum, 1 minute nap, another bunch of Autovacuum, 1 minute nap. In this way, there was no longer lag on the other side because it gave to the slave some sort of moment to breathe. But there was Autovacuum running for weeks over the large tables. We know which one it is. But that was perfectly acceptable because Autovacuum per each run is absolutely transactional. So the changes are always visible. There's not one transaction that be rolled back if Autovacuum gets skills in some way. So workaround in this case. But yes, in the meanwhile, that was beautiful. The closeless engineer decided to shard the business intelligence. The BI became big, up to 3 terabytes of data. So I say, okay, let's split in 3 smaller databases. Okay, these databases were created using the hot standby copy, so physical copy, and then the data was cleaned up, so each database contained 1/3 of the original database, so pretty small compared to the initial size, so 1 terabyte each one. But the daily dump, it was even misery. It was in misery. There was the slightly largest database in the triptych, in the 3 databases that approached very, very dangerously the 24 hours. And so, how to solve this thing? Slowish dump. What's the problem? For understanding why it's so slow, we need to understand how pgdump works. Pgdump is not different from any other client. It's just a very sophisticated tool that connects to the database, queries the system catalog, dumps the definitions, and then pulls out the data in a specific format called the copy format. It's a tab-separated values. It can be CSV. It can be, but by default, it's just copy. It's this tab-separated values. One of the good things of pgdump is to have a compressed format. So the data is stored in gzipped format and is searchable. So it's fine. But the problem is the copy, the compression, happens on the receiver database. So it means all the databases, all the three databases flown through the network and filled up the network occupation on the receiver's backup server. And plus, the backup server, it didn't have a very good CPU, so all the compression, it took a very long time. So network filled up, plus the CPU, it took very, very long time. So how to solve this thing? Another big bunch of bash. Lovely bash. I love bash. This script, it was created in the very early days of 2013, evolved on different ways, changing over the years. Meanwhile, the database were upgraded. So what it does, this script? It can dump the database in custom format locally. So, and more important, it dumps through the Unix socket and not the TCP stack. So it's even faster. It uses the CPU, and good thing, generates an MD5 checksum from the dumped file, copies the data across the network, and checks the MD5 and sends a message to the Nagios to say, okay, backup good, or oh, MD5 checksum failed, or remote copy bad. And plus, it did another interesting thing. If the backup was interrupted for some reasons, the local broken file was removed in order to preserve the space on the backup location. Plus made a lot of things, incremental backups, but in general it was this thing. There was also possibility to configure the with the capital F option, having the plain or directory format, but it was never used. At this level, I forget one interesting thing. The database versions were absolutely mixed. Some 9.0, some 9.1. So it was a mess with extension not updated, with extension, the App Store extension not that. It was, we will talk about App Store later. So this result, it was dropped dramatically, just 5 hours, including copy and checksum verification. Very, very good. But the business grow, the data grow, and all the speed, it was just because of very, 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 very expensive SSD storage. The BI increases, and the only accepted solution, take it between quotes, was to just reshard and reshard and reshard. So by the end of 2013, all the databases in total were 15 terabytes. 1 year, from 2 to 15 terabytes. It was a big bunch of data. And in the meanwhile, our hero upgraded all the databases to the 9.2. Thank you, Bruce Momchan, and your PG upgrade. It's an amazing tool. He made a fantastic job. And we move into 2014, the Battle of 5 Armies. This is, this was crazy. Our friend Boromir does not simply survive the Battle of 5 Armies, but our DBA survived. So he's he was able to survive. So 2014, it was after Christmas, after the Christmas break, everything fresh, and then backup performance issue. Again, dump size again started growing and growing. This time, looking to the monitoring system, there was a CPU increasing constantly over the time, not just peak, but just general occupation of the CPU. And that's what crazy. And most of the shards had the table space moving at 90%. So most of the data was moved from the expensive SSD disk to spinning disks, slower spinning disks, because there simply was no space to host this data on the SSDs. Because there was, these SSDs had a limit of number of devices to be installed inside the machines. So, again, how DBA was able to address the problem. And what we have here, inside the BI database, there was this table, which was in general it was a materializing view. It was just a one long table with a very long row, partitioned in some way, and that table had an harmless edge store field. Edge store, key value store, not structured data, technically text with an either, double pipe separated text as far as I remember, and everybody had a new key, so change the application code, create new keys to be stored automatically without alter table. Fantastic, right? Nobody needs to alter table anymore. But the problem, nobody did housekeeping of their data. There was rubbish stored inside these tables. And even when you deleted these keys, the data stayed in place because it was no longer visible by the application. But the database didn't know how to clean up. And over the year, the row length jumped from 200 bytes to 1200 bytes. And each BI shard contained up to 2 billion rows. There are any questions? So, how to solve this thing? The clueless engineer was the biggest problem, not the migration itself. Migrating with data is simple if you know what you're doing. And the databases, after all, are very stupid systems, like every information technology system, so they just do what you say. The problem, the human. Oh, I need to add the alter table. Oh, we are moving back to the column now. But against all odds, the migration was successful. Sorry, Oleg Bartonov. I know you made this fantastic thing, but HStore is an interesting tool. It's like JSON. JSON is a very good tool, but you need to know how to use it. Otherwise, you can kill yourself with a Swiss knife if you are not careful and you know how to use it. It's exactly the same thing. And the structure, it was not optimal for the usage of the HStore. But the result, storage usage dropped by 30%. Everything, all the numbers, instead of being stored as text, were stored at pixel length. And CPU usage dropped by 60%. And that is a very subtle thing. RTBA was incredibly surprised. He didn't expect this thing. The reason is because it's the way Postgres manages the data in memory. The data, when it moves from the raw datum on disk into the memory, is converted into the real data. There's a big bunch of subroutines that do this thing, looking over the system catalog. And that happened for the HStore fields. Whether it was read or not, the CPU was used for the conversion. And because the edge stored differently from JSON and JSON-bit, which is part of the core, it was an extension with a shared library, this was causing more and more context change and causing the CPU churn. And the result, Acme speed, woohoo, boosted incredibly. And Acme saved a big bunch of money in new hardware, otherwise required to share again the new databases. Fantastic, right? In the meanwhile, the RDBA knew, and they say this was just a workaround. The problem was the suboptimal schema. It wasn't a very solution. And they say, you ask the closest engineer to fix this thing, but the engineer, they were so busy to create new things. And he said, you have 1 year, guys, fix it. But nobody listened. So we move into the next year, 2015. This is Sparta. That was an exciting year. I had to say so, but I told you so. Can't be applied today, right? As predicted, the backing up of the BI databases increased again, up to 22, 23 hours. Sometimes there was 2 PG dump running all together on the same database. Very nice, right? With all the happiness of the transactions. But there was an interesting thing. We were on the 9.2, and in the meanwhile, there was the 9.3 release. Wow, the 9.3 release introduces the parallel backup. Fantastic. We can upgrade to the 9.3, right? And use the parallel backup. No. I hate that because I love Postgres. But that release, it had every minor release. There was a corruption bug, sub-transaction. The biggest problem it was the way the multi-exact ID were moved from the storage on disk inside the tuple, and the code, it wasn't sufficiently tested. It required several minor releases to fix the horrible bugs, corruption bug with data loss. So because our DBA is very conscientious and very conservative, he never considered the 9.3 as a production ready, but he craved for the parallel backup, how to do it. The parallel backup, it was just an extension, a tool, the PG dump, using an existing feature introduced in the 9.2. The 9.2 added a very obscure feature. It's called snapshot export. What is a snapshot? A snapshot is a static image of the data consistent, one of the parts of the ACID paradigm, where you can read the data consistently across the database. And if you start a session, export this snapshot, which is just an identifier, and import this snapshot into a different independent session, you will see the same transaction snapshot from the original session, which is fantastic. So it was possible to export in parallel from the 9.2. Yes, but how to do it? In this case, the Debian packaging helped our DBA, because the Debian packaging allows different versions of databases, different versions of clients. So our DBA installed the just the client of the 9.3 and used the PG dump of the 9.3 to dump the data on from the 9.2. Fantastic, right? Yeah, in parallel, all fast. Yeah, it requires some changes, obviously. The original backup script, the original bash script, required the -j parameter, like the PG dump, to specify the number of jobs, and the check for the 9.3 client installed, otherwise failure, And yes, this is one caveat of the parallel dump, because the only way to dump independently the data, because do you remember, is still copy format. The only way to dump the data is still is the directory format. The directory format is interesting because it's just a directory with the name of the dump, with a doc file inside, and gzipped files, one for each table. And inside this gzip file, there's the copy command for restoring the data into the database. So override the directory format, otherwise the command will fail. And adapt the checksum procedure, instead of working on one single file, work over all the dumped file inside the directory. Pretty nice, right? Just a little infinitesimal catch. There was the restore script, because do not forget, there's no, the backup is just to be considered not existent if you cannot restore successfully. So we had there was this restore test, automated or not, in some way automated. When restoring into the 9.2, he complained about this lock timeout. Is a new parameter introduced in the 9.3 that adds a timeout if the session cannot acquire the lock, but it's absolutely fine. It's just an harmless problem, just an harmless comment. But the data was restored, it was healthy, it worked incredibly fine. It's not safe because there are different versions. Obviously, everybody will say you cannot do this, but it was an extreme measure. The other measure it was running without the backup. And after all, the restore worked pretty well. Because the 9.3, obviously, adding the parallel backup over the directory added also the parallel restore. So it was fast in backup, fast in restore. But schema still the same of the 2013. Bad, 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 bad. So with just six parallel jobs, the database was affected. The clients was massively affected because the I/O, it was so intense by just the normal activity of the database that the I/O activity, that just 6 jobs in dumping data affected this database. Dropping to 4, it was quite good. The database, it wasn't too much affected, and the result, it was, forgot something? Oh yes, and the backup is the speed record since 2013, under the 5 hours in some places, incredibly fast, very, very good. And in the meanwhile, our hero, in August of Fire, every bloody Sunday night of August, upgraded all the databases which were sharded and resharded and resharded again to the version 9.4. From 9.2 to 9.4. It was exciting, it worked incredibly well. And thank you again, Bruce, because this version introduces a dump reload of the schemas in parallel, and speed compared to the upgrade from 9.0, 9.1 to 9.2, it was probably 6-7 times faster. There was the 6 database a night, there was the upgrade. Very, very good. And can we reach 2016, right? Breathe. Oh, it's still breathing. He's breathing, right? He's breathing with an accessory, with something helping him, but he's still breathing. And we are New Hope. Any reference to Star Wars is absolutely wanted. The upgrade improved the performance issues. The 9.4, usually when the new major version of Postgres comes in, there's a free of charge improvement of speed in general, except some corner cases, like the multi-transaction ID. But in general, the move from 9.2 to 9.4, it was a success. The database improved, it worked very well, and our DBA had some time to fix things. So the script to ship the archival wall, it was improved. multiple replica, to set up cascading replica, set up as many as you want of the slaves, or even shipping the data across the network in compressed way to have a secondary data center and make everybody very happy about this thing. Each slave had this script had the dedicated rsync process in parallel, configurable with compression and protocol, rsync or SSH over rsync. Obviously, rsync is much, much faster because there's not the overhead of the SSH. Using this way improved also the ship over the network. And also the script queried each slave and used the, yes, it was a pain in the back because the data type from 92 to 94 it changed for querying the PGX log status, for getting the PGX log name, changed from text to PGXLI, I think. So after the upgrade, all the scripts were broken. But yeah, Magnus, he joked. We have to drop you your script, yeah, right? Next time it will be the 9.6 with the change of the session status. Everything will be broken, and do not forget the 10. All the scripts using the numbering will be broken with the 10. I love this thing. And so the script worked pretty well. If any slave was in delay, it didn't change, deleted the wild files, and it worked quite good. And also, the init standby script switched from the rsync over SSH to rsync. It worked incredibly well. The restore script take advantage of the alter system. Finally, in the 9.4, we have the alter system. We can change the configuration using the SQL prompt, which is something I really, really, really wanted since I left Oracle in 2007. Yeah, in Oracle, there's the alter system. It was introduced, I think, in the 8i, as far as I remember, I think, or 9i. But yes, it was long time ago. So now we have the alter system, and it's fantastic because you can dump a production settings, you can store the restore settings, so you can change on the fly using an bash script, and then speed up the restore. And the restore was incredibly fast. Just 9 hours for the largest database, 4.5 terabytes on disk, on spinning disk, not on SSD. It was incredible. And working with bastard operator from L Junior, finally our DBA was able to wrap the backup manager, Barrios, into the pre and post execution hook, so he was no longer responsible of the backup itself. There was this automated tool that dumped the data, copied it into the virtual tapes, and then deleted the data after the dump, the successful dump. And finally, a big bunch of these automated scripts were deployed using DevOps tools, and also Ansible. So let's go for the wrap up. We have this. This is an intelligence database at a glance. This is interesting because it shows how the data moved and how it increased. The first year, 2012, it was one database, 2 terabytes of data, version 9.1. 2013, 6 databases, 3 terabytes, 15 terabytes of data. The average. This is wrong because it's 5 databases. It's fixed on the slide share. It's not fixed there, sorry. But it was just 5 databases, each one 3 terabytes, 15 terabytes in total by the end of 2013. So it jumped from 2 to 15 terabytes in just 1 year. 2014, 9 databases, 19 terabytes, and the average says 2.2, caused by the edge store removal. The space dropped dramatically. 2015, 13 databases, 32 terabytes. By the end of 2016, no, by the middle of 2016, it was 17 databases, 43 terabytes, 2.5 in average. Not because something changed, but just because I omitted the final part. Our DBA added a combination of cleanup plus a very, very interesting tool called pgrepa that does the vacuum full online without blocking anything. In this way, the space, it was under control, but I don't think it's still under control anymore, right? So let's go forward. Few words of wisdom. Our old grumpy. Back in my day, we had only 640K, right? Standard memory. Then was the, how it's called? The extended memory for adding more megabytes. Wow, this was amazing. Yes, reading the product source code is always good practice. Understanding what is written inside is much, much better. And this is not just related with Postgres. It's related with everything. Any product you want to use it. If you have access to the source code, read it and understand what it does. Bad design can lead to disaster, in particular if the business is successful. Yes, I know what you're thinking. If in doubt, ask for your DBA for advice, and please listen to him. If you don't have a DBA, hire him, or either. I found a lot of women choosing this unfortunate career. And yes, this is one just little quote I found on Twitter. And one bad programmer can easily create 2 new jobs a year. It's your choice if new programmers to fix their crap, or a sysadmin DBA to hide the crap under the carpet. And finally, there are any questions? Yeah?
About the join command in Bash.
Sorry?
Do you know about the join command in Bash?
Join?
Yeah, you were iterating over your arrays of bits. I'll leave the join command and wait for all of them to exit.
I used a different strategy because it was used by a crazy DBA I met in my first job. But yeah, maybe it can be used. But using a simple loop function that queries the, it just run a kill dash 0 to the process ID. If it returns 0 is fine. If it returns different from 0, it means the process is no longer there and the PID is evicted from the array. But yes, it's another way. Somebody else? Boring legal stuff. This is all the images I grabbed from and or created. The angry old man I created by myself. Plus others from mostly meme generator. I love that website. It's absolutely fun. Yes. Good for sharing on Slack or Telegram or whatever it is. The usual contact and license, Twitter for Dr. Scout, PGDBA, the meetup. We are 77. Very nice. It would be good to have more people coming to these talks. And obviously, the document is distributed under the terms of Creative Commons license. That's it. Thank you very much, and have a good night. Good time.